Welcome back to Pocket Run. Hey, where are you going? It's just math. Don't run away. Hey. Oh, well.
Alright, let's look at 27b1. Basically what you are doing is, in these problems, you will be graphing an estimate of this, and what our goal is to find the points where they intersect. So, yes, you probably could do an estimate on the graph to find the points of where they intersect, but we will calculate everything because calculating is exact. Graphing is an estimate. So first you need to recognize this is a line. So if I graph this as a line, my y-intercept is 4. So graphing that as my y-intercept. And then my slope is 1. 1 over 1. So rise up 1. So right now I am just estimating on my graph, okay? In a minute I will go graph it on graph paper. But here, and that's not a very straight line, that is just an estimate. Okay, then this, I recognize it's a circle. Okay, my coefficients are 1, they're the same. I've got a plus sign, both my x and y squared, both x and y are squared, so it's a circle. So when there's no parentheses, then my center for the circle is the origin. My center is 0, 0. Then my radius is the square root of this. So my radius is 5. So if my center is the origin, and then my radius is 5, I'm going to count out 5. On all directions. So I'm just graphing this as an estimate. So if I extend my line out, so I can see now just from an estimate I am going to have 2 points to where this line and this circle intersect. My goal is to calculate what is the coordinate of this point and what is the coordinate of this point. So we do that by calculating. So you're either going to be using a substitution or elimination in most of these problems. So I can see here that y equals this. So I can use substitution. So I can take this and substitute it in for y. So you're going to have to keep up with this. So here's x squared, and then I'm going to substitute in x plus 4 for y, but I am squaring it. Don't lose that exponent. Y is x plus 4, but then I need to square it. Okay, then I'm going to, this will be a quadratic equation. If you need to write it out like this so that you FOIL out x plus 4 times x plus 4 correctly, then please write it like this. So FOILing that out, that would be x squared and then plus 4x plus 4x plus 16 equals 25. So if I combine my like terms, I can combine these two like terms. X squared plus x squared is 2x squared. Combining my 4x's together, 4x plus 4x is 8x plus 16 is 25. I am trying to solve for x because I need to solve for x. That will give me x coordinates, and then I need to solve for y for my y coordinates. How do I solve for x in a quadratic equation? The first step is to set it equal to 0. So I need to move my 25 over and set this equal to 0. So then I have 2x squared plus 8x, 16 minus 25, I believe that's negative 9, equals 0. So, okay, so now that I have this, there were several options of solving for x. How many solutions should I have? 2. So our options were either factoring, I am pretty sure this doesn't factor, or you complete the square, or quadratic formula. Well, if you complete the square, you can't have the 2 here. Most people will not choose to complete the square. Quadratic formula comes from completing the square. So I would always opt for, if this does not factor, you use quadratic formula. So we're going to use quadratic formula. As a reminder, this is your a, your coefficients in front are your a and b term, and then the whole number at the end is your c term. So quadratic formula is x equals negative b, and then my b is 8, plus or minus square root of b squared. That will be 8 squared minus 4 times a, which is 2, times c, which is negative 9. Keep up with your negative signs. All over 2a, and a is 2. Alright, so now let's go to simplify this. So x equals negative 8 plus or minus square root of 64 minus a negative. I'm going to have a positive. 4 times 2 is 8, times 9 is 72, all over 4. So it's going to be negative 8 plus or minus square root of 64 plus 72. That would be 136, all over 4. So when you get to this point, remember you're going to have two solutions. So when you get to this point, since we are trying to find a coordinate on a graph, then I would go ahead and change all radicals into decimals. Alright? So, because since we are graphing, then we need to change radicals into decimals. Since we don't know where radicals are on a graph, we usually do it with decimals. So, square root of 136 is basically, I'm rounding to 2 decimals, 11.66. So essentially what I have is a negative 8 plus 11.66 divided by 4, then negative 8 minus 11.66 divided by 4. So I am going to do both of those numbers, so negative 8 plus 11.66 and then divided by 4. That came out to 0.915, so I'm just going to round to 0.92. That's one of my x values. And then now I'm doing negative 8 minus 11.66. And then divided by 4. And that comes out to a negative 4.92. So, if I was to draw an XY chart, I came up with two values. Remember, I should be coming up with 2 points. So I should have 2 x values. I need an x coordinate for each one of those points. So one of my x coordinates is 0.92. And then one of my x coordinates is negative 0.492. So how do I find my y coordinates? Well, these were my x coordinates. So take your x coordinates and plug them back into one of your original equations to find your y coordinate. Well, which equation do you think is easier to plug back into? The line or the circle? Well, I believe it would be easier to plug it back into the line. Alright? So now what I'm going to do is take my x values and plug them back in for right there to figure out my y value. Okay? So, in doing that, down here, so if I said, so I'm plugging this back into this equation right here. Okay, so y equals, put in my 0.92 for x plus 4, and one of my y values would be 4.92. So, make sure you put this in your little chart, in your little table correctly. When x is 0.92, my y value is 4.92. Okay, now let's determine when x is negative 4.92, plugging it back in right here, negative 4.92 plus 4. A negative 4.92 plus 4 would be a negative 0.92. So, when my x value was negative 4.92, my y value was negative 0.92. I can take these and put those on the graph to, this was just an estimate. Now I can go back and see, do these values match my estimate? If not, I need to fix my graph to where it's a little bit better. Okay, we're graphing 27b1. Remember, we had a circle with a radius of 5. So here was my circle, and then here was my line with the y-intercept of 4 and a slope of 1. So the points that we calculated for the intersection were x equals 0.92, y equals 4.92. So if I go here and I'm going over barely to 1, 0.92 and up 1, 2, 3, 4 and almost to 5, that's pretty close to where my intersection is right there. And then my other intersection point was negative 4.92. So 1, 2, 3, 4, almost to 5, and then down 0.92, almost -1, and that's pretty close to where my point is there. Again, on your graphs, it's just your drawings will be the estimate, but your actual calculations are your actual answers. Okay, we're looking at 27b4, so I have these two equations. I need to recognize what are these equations on a graph. First off, I'm going to look at this one. X equals y squared. When one is squared and one is not, it's a parabola. When y is squared and x is not, it's a left-right parabola. Since this coefficient is positive, it's facing to the right. And since I have no other numbers out here added, it starts at the origin. So the vertex is at the origin. So just as a rough estimate, because I have no idea how wide the parabola is, that's where it just becomes an estimate. So I have a parabola that looks something like this, okay? And again, that's just a rough estimate. I didn't draw that very well because it should be symmetrical, and I drew one a little wider than the other. Anyway, this first equation, 4x squared plus y squared equals 4. When x is squared and y is squared and there's a plus sign in between, there's only two choices, ellipse or circle. My coefficients are different because this is a 1, this is a 4. When the coefficients are different, it's an ellipse. So when it's an ellipse, you have to determine your axis points or your extremities. So how do you do that? Okay, first off, since there's no parentheses, then I know that my center is the origin, okay? Because this would be the same as saying x minus 0 squared. X minus 0 is x and x squared. So when there's no parentheses, your center is the origin. So I know that my center is the origin. So how do we find the axis point? We let each one of these equal 0. So we let x equals 0. When you let x equals 0, the only thing you have left is y squared equals 4. How do you solve that? You take the square root of both sides. Square root of both sides means y equals square root of this, 2. And then what do you put in front of your radical? Plus or minus. Okay, so plus or minus 2. Again, just to show you where that came from, y squared equals 4. You should have done this in another lesson, that's why I'm going through it pretty quick. So that would be y equals plus or minus 2. So when x is 0, my y value is plus or minus 2. So on the graph, I know my extremities. When x is 0, don't go anywhere in the x direction. I've got a positive 2 and then a negative 2, positive 2, then negative 2 for my extremities on the y-axis. So then you let y equal 0. When y equals 0, that whole term goes away, and then you have left 4x squared equals 4. Solving for x, divide both sides by 4, and then you have x squared equals 1. Take the square root of both sides, put your plus or minus in front of your radical, so x equals a plus or minus 1. So when y is 0, x is plus or minus 1. So going in the positive and negative direction for x, positive 1, don't go up anywhere in the y direction, negative 1. So those are my extremities. So that is what my ellipse will look like. So you can see now that we're going to have 2 points of intersection. That is our goal. Our goal is to calculate the coordinates for these 2 points of intersection. That is the end goal. So we should be coming up with coordinates for 2 points. How do we do that? We either use substitution or elimination to actually calculate it. We're not going to estimate it from the graph. We're actually going to calculate it. So going back to our equations, you look at, can you do substitution or elimination? We could do elimination, but for this problem, substitution is easier. So you have to look at what can you substitute. We normally substitute in, we look at x equals y squared, and we want to substitute this in right here. But let's look at the reverse. Let's look at it as y squared equals x. So if y squared equals x, then we can take this y squared equals x. We can take this and put it in for right there. Y squared is x, therefore we can put in x right here. So if we do that, then we're saying 4x squared plus, and instead of putting in a y squared, we're putting in x. We're substituting x equals 4. I now have it to where I'm down to one variable. I have a quadratic equation. Quadratic means your highest exponent's 2. How do I solve a quadratic equation? My very first step is to always set it equal to 0. So then I have 4x squared plus x minus 4 equals 0. So you want to look to see if it factors. If it doesn't factor, most likely you're not going to complete the square. You'll use quadratic formula. So if it does not factor, my recommendation is use quadratic formula. So again, for quadratic formula, A, B, C. So what is my number for B? What's the coefficient in front of here? 1. So we will use 1 for B. So using quadratic formula to solve for x, x equals negative b, and b is 1, plus or minus square root of b squared, and b is 1. 1 squared minus 4 times a, and a is 4, times c, and c is negative 4. So keep up with your numbers. All over 2a, 2 times a, and the a is 4. So simplifying all of this, negative 1 plus or minus square root 1 squared minus a negative is going to end up becoming a positive. 4 times 4 times 4, 64. 4 cubed is 64. All over 2 times 4 is 8. Okay? Simplifying this some more. Negative 1 plus or minus 1 squared is just 1, plus 64 would be square root of 65, all over 8. Again, since the main thing is we're trying to find a coordinate on a graph, we're going to turn our radicals into decimals. So I'm going to turn square root of 65 into a decimal. And that was, we're going to have negative 1 plus or minus the square root of 65 just to 2 decimals is, and you can even do to 1, 8.06 all over 8. So what does this mean I have? I have negative 1 plus 8.06 over 8 and negative 1 minus 8.06 all over 8. So let's do this one first. Negative 1 plus 8.06, then divided by 8. That came out to 0.88. And then now let's do our negative 1 minus 8.06 divided by 8. And that should be a negative number because you have a negative up here divided by a positive. Negative 1.13. So it's my recommendation to make you a little XY chart. This is the best way to keep up with all your points. We said we should have 2 solutions for x because we had a quadratic equation. So we had x equals 0.88 and x equals negative 1.13. That's a decimal. So how do we find out what our y coordinates are? Substitution. Take your x values and go back and put them into one of your equations. So in my opinion, here I'll just rewrite our equations down here. We had 4x squared plus 4 plus y squared equals 4, and then x equals y squared. In my opinion, it's probably going to be easier to put it here. So you can take these values that you have for x, substitute them in right there, and then solve for y. So if I did that, first off I'm going to substitute in my 0.88. Put in 0.88 equals y squared. Okay, so putting in 0.88 for x equals y squared. How do I solve for y? I take the square root of both sides. So this becomes y, and then you put a plus or minus. So the square root of 0.88 is plus or minus 0.938, which I'm going to round to 0.94. So the square root of 0.88 was 0.94, a plus or minus. Okay, going to leave that solution there for a second before I go put anything. Well, in my chart, I can say when x equals 0.88, then I got a plus or a negative 0.94. Okay, now let's go do our x equals negative 1.13. So if I put in negative 1.13 right there, so negative 1.13 equals y squared. Solving for y, I have to take the square root of both sides. Okay, that would cancel. What happens when you take a square root of a negative number? Square root of a negative number gives you an imaginary number. We do not graph imaginary numbers. So if you come across a square root of a negative number, that is no real, because we only graph real numbers. There's no real solution to that. So there is no coordinate that matches with that x value. So you can come over here to your chart and that there's no solution for that one. So we should come up with 2 points, and we did. Our 2 points that we came up with are 0.88 and then a positive 0.94. That's one of our coordinates. And then a 0.88 and then a negative 0.94. These are our 2 coordinates that we can then go graph on the graph with our estimate. Okay, we're graphing 27b4. So this first equation is an ellipse, and I have it graphed right here. Remember, my extremity points on the y-axis was plus or minus 2. On the x-axis was plus or minus 1. So there's my ellipse. Then I have a parabola that faces to the right. I'm not going to graph my parabola until I graph my points. Normally I do not graph my parabola or hyperbola until I graph my points. So we calculated our points to be when x is 0.88, we had a positive 0.94, and then when x is 0.88 to be a negative 0.94. So going over about 0.88 is just an estimate, and then up 0.94 puts a little point right there. Then going over 0.88 and then down about negative 0.94, I'm on, remember, these points have to land on the ellipse because it's where the parabola and the ellipse intersect. So knowing that, then I'll just kind of estimate my parabola. Like here, my parabola needs to go through these points. So those are my points of intersection. Okay, we're on 27b6. Just to tell you that there is no like set way to do every one of these problems the same. They're all going to be a little different. But you just have to know the idea of graphing the equation and then either using substitution or elimination to calculate the actual coordinates. So here, the equation of y equals 3x squared. I recognize that that's a parabola. It's an up and down parabola, and it's going to start at the origin because there's no, I'm not adding a number out here, shifting it up or down. And then this number tells me it's going to be a narrow parabola. So just to, again, since it's an estimate, I'm just estimating it. It's going to look something like this, but I don't know how narrow it is. I recognize this as a circle. X squared and a y squared term, and then they're added together, and then there's no parentheses, so my center of my circle is the origin, and then the square root of this is my radius. So my radius is 4. So just going out with a radius of 4, and again I've hand drawn this, so this is just a estimate. Then something like this. Basically I do an estimate so I can see how many points it is I'm trying to calculate. Well, the parabola and the circle intersect at 2 points. And these points I can get an idea of the coordinates because I can see it's somewhere close to, the x coordinate is going to be something lower than 2 and something up here close to 4. So at least the estimate helps me to know when I calculate my answers, am I getting close to where these points are? So this is just an estimate to help me to see are my calculations correct. So now we go back to the equation. You can either use substitution or elimination. Well, if I use substitution in either way, then I'm going to get an x to the 4th or y to the 4th. I'm going to get something to the 4th. You don't ever want exponents up to the 4th power. Okay, we haven't calculated equations to the 4th power. So if you do substitution and you get something to the 4th power, you need to do elimination. How do we do elimination? Elimination is usually where you have x's and y's on the same side and you line everything up. Okay, so if I move my parabola to where I have x's and y's on the same side, and then I try to line everything up, you can see I have a y term and an x squared term. Here there's an x squared term and a y squared term. Well, this doesn't have a y term in it like the parabola does. Alright, So here's what you're going to have to do. You have to make a column for everything. So both equations have an x squared term. Okay, so I'm going to line up my x squared terms. My circle has an x squared term, and then the parabola has an x squared term. Okay, my parabola does not have a y squared term in it, so I can just write 0y squared here. Okay, but my parabola does have a y term in it, right there. But my circle does not. So I can do this for a 0y. And then the whole numbers at the end, my parabola was 0, and then my circle was 16. It's just a matter of writing everything correctly. I still have my circle, x squared plus y squared plus 0 equals 16. My parabola, still negative 3x squared plus y. I just added in this as a placeholder. Okay, so when you do elimination, remember you are adding your equations out here. You want to add to where something will eliminate. Well, it doesn't make sense to eliminate y's because I cannot eliminate my y squared terms and my y's at the same time. So the best thing to eliminate is my x squared terms, because then I'm only left with y's. I'm trying to be left with only one variable. So then I'm only left with y's, and then I can make a quadratic equation out of my y's. So usually you eliminate the variable that only has one term. X is only in one term, so I'm going to eliminate that. So if this is a negative 3x squared, what does this need to be in order for it to go away? It needs to be a positive 3. So I have to multiply that by a positive 3. If I multiply that by a positive 3, I have to multiply everything by a positive 3, every term. So writing down my new equations, I'm going to go over here and write my new equations. This would be 3x squared plus 3y squared. 3 times 0 is 0, so that's still 0y. And then 3 times 16 should be 48. So then I'm adding my equations together. This bottom one, the bottom equation doesn't change. Okay, now I can add them together and my x squared terms go away. 3y squared plus 0y squared is still just 3y squared. 0y plus 1y is still just 1y. And then 48 plus 0, 48. So now I have a quadratic equation. How do I solve quadratic equations? Set it equal to 0. So now I have the equation of 3y squared plus y minus 48 equals 0. How do I solve quadratic equations? I'm either going to factor or I'm going to use quadratic formula. So here I'm going to use quadratic formula. That is my A term, B, and C. So my B term is a 1. So notice I'm solving for y. So instead of putting x equals something here, I'm going to put y equals, because I am solving for my y, which will be my y coordinate. It's important to keep up with that, to know, are you solving for your y coordinate or your x coordinate? So using quadratic formula, negative b, which is negative 1, plus or minus square root of b squared, 1 squared minus 4 times a, and a is 3, times c, and c is negative 48, all over 2 times a, and a is 3. Simplifying under the radical, negative 1 plus or minus square root of 1 squared is 1, minus a negative, that will be a plus. So now I've got to do 4 times 3 is 12, and 12 times 48 is 576. All over 2 times 3 is 6, so that's going to be negative 1 plus or minus square root of 1 plus 576 will be 577, all over 6. I'm going to turn that into a decimal. So basically I have y equals negative 1 plus or minus the square root of 577 is 24.02. Pretty much could just use 24 probably, divided by 6. I'm still going to carry it to 2 decimals. So this is a negative 1 plus 24.02 divided by 6, the negative 1 minus 24.02 divided by 6. So is what it looks like. Negative 1 plus 24.02 divided by 6, and then you have a negative 1 minus 24.02 divided by 6. It's important to do your numerator first. So do your negative 1 plus your 24.02, then divided by 6. This comes out to 3.84. And then a negative 1 minus a 24.02. And then divided by 6 comes out to a negative 4.17. So these were your y values. Okay, so if you made you a little XY chart, which I recommend you do, these are y values. You have a y value of 3.84, then you have a y value of negative 4.17. Now we've got to calculate our x coordinate for those y values. How do we do that? We go back to one of the original equations. So you take these values and you substitute them back up into one of your original equations. So I personally think it would be easier to substitute them back into this equation right there. So here we are. We have these y values, and you can substitute them into the original equation. I think it's easier to substitute it into this equation. So first I will put in 3.84. Remember, I'm substituting in for y. It's important to keep up. Is that a y value or x value? So putting that in for y equals 3x squared. Solving for x, divide both sides by 3. So 3.84 divided by 3 is 1.28 x squared. Take the square root of both sides, putting in your plus or minus in front of your radical. The square root of 1.28 is 1.31 plus or minus. So we said that when y, going back to your chart, when a y is 3.84, you got a plus and a minus 1.31. Okay? So now let's take our other value of negative 4.17 and we're putting that in for y. So negative 4.17, we put that in for y. You can kind of see what happens. You can eventually see that we're going to be taking the square root of a negative number. So, okay, a negative divided by a positive is a negative, and that would be a negative 1.39 equals x squared. When you take the square root of both sides, when you take the square root of a negative number, what happens? You get an imaginary number. So that means that there are no real solutions. We are not graphing imaginary numbers. So going over here to your chart, when y is negative 4.17, that's no real solution. Don't always assume that if you have a negative number here, it's going to work out like that. Okay? Put it back into your equations and let your equations tell you if that's the case. Sometimes you can have negative values in your coordinates. So now what this tells us is that when y is 3.84, make sure you put that into your right spot. So when y is 3.84, that's our y coordinate, we get an x value of 1.31. Also, when y is 3.84, we get a x coordinate of negative 1.31. These are the 2 points where those two, the parabola and the circle, should be intersecting. Alright, we're graphing 27b6. So one of the things is we have this, we have a circle with a radius of 4. So there's my circle with the radius of 4. And then I have a parabola that's facing up. I don't graph my parabolas until I've graphed my points, since most of my parabolas are just an estimate. So we calculated our points that we were going to have a plus or minus 1.31 for x. So when x is 1.31, our y came out to 3.84. Actually, I think we calculated y is 3.84. And then when y is 3.84, we got a plus or minus 1.31 for x. So, graphing this coordinate of 1.31, 1.3 is just estimate, and then up 3.84, 1, 2, 3. Remember, the point has to be on the circle because that's where the parabola and the circle intersect. Then at a negative 1.31 and then up at a positive 1.384. then my parabola should intersect the circle at these points. So in this parabola starts at the origin and it faces up. So I'll draw my parabola to where it goes through those points because that's where the parabola is going to intersect the circle. Okay, we're looking at 27D, 1 through 6. We have these two equations. They look real similar, but the one thing you notice is one has a plus sign, one has a subtraction sign. When you have a plus sign, these coefficients are the same. This is a circle. Subtraction sign, hyperbola. Okay, so looking at this circle, I see that the center is going to be at the origin, and then taking the square root of this is your radius. So square root of 32, that's not a perfect square. So that means square root of that, the radius is about 5.7. Okay, that's close enough to estimate on a graph. So if I go out to 5.7, almost 6, I'm just going out to almost 6 at every, this is why it's an estimate, at every place on my graph, then there's my circle. Okay, this is a hyperbola. So you have to know, or you can look at your formula sheet, which way does a hyperbola face? When you have your x squared term first, it's going to be a c and backwards c, which means I will be crossing the x-axis. So how do you determine where you're going to cross the x-axis? When you have this, if I know I'm going to cross the x-axis, that means I'm going to let y equal 0. So because when I'm crossing the x-axis, my y-coordinate is 0 on the x-axis. So that term will go away, which means I have x squared equals 18. So solving for x, take the square root of both sides. So x equals plus or minus, and then turning that into a decimal, 4.2. So when y is 0, meaning you're not going up or down either way, you're on the x-axis, we're at plus or minus 4.2. So coming over to here, 1, 2, 3, 4, a little bit like that. 1, 2, 3, 4, somewhere here. I'm crossing the x-axis here, and I have no idea if my hyperbola is wide or narrow, so I'm just drawing it like that. The only thing that this gives me an idea, I have no clue, my parabola, my hyperbolas could be narrower than this, or it could be wider. So the reason I'm drawing myself an estimate is because I see now that I'm going to have 4 points of intersection. So I should be calculating 4 coordinates. I should have 4 x coordinates and 4 y coordinates. I should have 4 coordinates as my final answer. I'm not going to graph this one on graph paper for you. I'm just going to leave it as an estimate, but I am going to calculate the coordinates. The main thing I wanted you to see is that an estimate of a graph shows you how many points of intersection you're going to have. Okay, so looking at my original equations here, then I asked, do I want to do substitution or elimination? Well, they're already all stacked one on top of each other, and if I added them together, then I can see that my y-square values are going to eliminate. Alright, so I'm going to use elimination to calculate these. Because the idea is you're calculating, either you're solving for x and then you go back and solve for y, or vice versa. So if I add these together the way that they already are, my y-square values will eliminate. So remember, this is a coefficient of 1. 1x squared plus 1x squared is 2x squared. Adding these together, that should be 50. And then dividing both sides by 2, because I'm solving for x squared. X squared equals 25. I'm solving for x, so take the square root of both sides, put my plus or minus. So x equals plus or minus 5. So I'm going to start myself a little XY chart. So when x is plus or minus 5. If you want to write it as when x is a positive 5 and negative 5, that's okay too. The idea is you're supposed to have 4 points. So when x is plus or minus 5, now how do you solve for your y coordinates? You go back and put it into one of your original equations. So I'm going to put it into my circle only because that's a positive sign. So when x is plus or minus 5, I need to take both of these values and put them back in here for x. So the first one I have to do is a positive 5. So when x is a positive 5, then I have this. Okay, putting in 5 here. So 5 squared is 25 plus y squared equals 32. I'm trying to solve for y, so I need to subtract this to the other side. Y squared equals, I think that would be 7. So solving for y, take the square root of both sides, put your plus or minus. So y equals plus or minus, and then the square root of 7 is 2.6. So here's where it gets tricky of keeping up with your points. When when x was a positive 5, so over here, when x was a positive 5, I got a value of plus or minus 2.6. Okay? Basically, that's 2 points right there. When x is 5, I got a positive 2.6. When x is 5, I got a negative 2.6. Okay? That's 2 coordinates right there. Okay, now let's go put in a negative 5, because first I had to put in the positive 5 for x. Now I'm putting in the negative 5. So if I go put in a negative 5 right here, is my answer going to change any? It's not going to change, because negative 5 squared is still a positive 25. So I don't have to go through all these calculations. I can just recognize that if I put a negative 5 here, I'm going to end up with my same equation, and I'm going to come down here to y equals plus or minus 2.6. So when x is a negative 5, I got a y value of plus or minus 2.6. What does that mean? When x is negative 5, I got a positive value of 2.6. When x is negative 5, I got a negative 2.6 as well. So these are my 4 points that should match my graph. And if we go back and look at the estimate, we said, okay, when x is a positive 5, 1, 2, 3, 4, 5, then we should have a 2.6. So according to my graph, my points need to be a little higher, which tells me that I did not draw my hyperbola wide enough. And then down here at negative 2.6. The same is true for a negative 5 when x is negative 5, 1, 2, 3, 4, 5. Then I would get a positive 2.6 and a negative 2.6 down here. So your points will tell you if you've drawn your hyperbolas or parabolas wide enough or too wide. So that's why it's important to actually calculate the actual coordinates, because this is just an estimate.